Problem 2. What is the inflection point of a function f(x)? Inflection point A of function f(x). So first, your f prime A, double prime A, your second order derivative at this point A should be 0. And second part, your second order derivative sign, right? The sign of the second order derivative should change. This should change before and after A. Okay, after passing A. For example, before A it's negative, then after passing A, it should be positive. Before A is positive, then after passing A, it should be negative. Okay, so let's check this function f(x). It's x to the power of 4 plus cx cubed plus x squared. So because the inflection point is related to its second order derivative, so its first order derivative is this, and its second order derivative is this. Right. Then when it doesn't have any inflection point, it's either you don't have any point that second order derivative equals 0. Right. So part A, if no inflection point, right, there are two cases. First case is no point such that the second order derivative is 0. Right. Or when the second order derivative is 0, but right, the second order derivative sign doesn't change after passing A. Okay, so let's see first. There's no point such that second order derivative equals 0. So the second order derivative is 12 x squared plus 60x plus 2 equals 0. So if this thing is no solution, we know that for a quadratic equation ax squared plus bx plus c equals 0, its no solution means no real solution. Okay, no real solution means what? Means your b squared minus 4ac, it must be smaller than 0. Right, so here your 6c squared minus 4ac must be smaller than 0, which means 36c squared is smaller than 96. C squared is smaller than, right, c squared is smaller than 8/3, which means negative square root of 8/3 is smaller than c, smaller than square root of 8/3. Okay, this is the first case. There's no point such that the second order derivative equals 0. Second case is there is a point that second order derivative equals 0, but the second order derivative doesn't change sign. So this case, it happens when the second order derivative equals 0, has only one solution. When it only has one solution, which means your c is positive or negative square root of 8/3. Okay, then you check its second order derivative. It's a quadratic function and there's only one solution, which means before and after this point, the second order derivative's sign doesn't change, right? Before and after the point, the second order derivative sign doesn't change. Okay, so that's why when c equals this, even if it has a solution such that second order derivative equals 0, because the sign of second order derivative doesn't change before and after, so there's still no reflection point. Right, so for question 1, the final answer is when c is smaller or equal to square root of 8 over 3, it's greater or equal to negative square root of 8 over 3. Okay. Then for part B, is it possible that there's only one inflection point? Okay. For one inflection point, it's impossible because you can check because we know the second order derivative is a quadratic function, right? For quadratic functions, there are only 3 cases. This case, we already proved there's no inflection point, right? This case, we prove, this case, only unique solution, we prove there's no inflection point. And otherwise, you have 2 solutions, then the second order derivative change twice, right? You can see from here to here, the sign changed from positive to negative. From here to here, the sign changed from negative to positive. So the second order derivative sign changes twice. So one inflection point, it's impossible. Okay. Then last part, 2 inflection points. Two inflection points is exactly like this graph, right? The second order derivative changed twice, which means what? Which means your second order derivative equals 0 has 2 different solutions. 2 solutions. Okay, which means your b squared minus 4ac should be greater than 0, right? So 6c squared minus 4, it should be greater than 0, which means your c is greater than square root of 8 over 3, or c is smaller than negative 8 over 3. Okay, and this is your answer for part 3. Okay.